Hi there, smart of you to tune into this episode of the Hygienic Design Strategy, in which we interview companies that actively invest in hygienic design product development as part of their business development strategy. Now, if you want to pinpoint the most valuable innovations that will hit the market in the coming years, it's wise to look at the current investment trails. And you can bet your money on those trails if they also show a pattern of company takeovers in a specific technology area. Now, when we look at what's cooking at EHEDG lately, we see an increasing number of sensor suppliers applying for EHEDG certification. So that points to the need of the food industry to gain real-time insights into their food safety, food quality, productivity, and sustainability performances. Now, in recent months, we also see that some companies are investing in even more innovative new types of sensors. And one of these companies is Lörke GmbH, a German company, Germany-based company that recently took over another company that laid the foundation for the development of a new type of sensor, a biofilm sensor for the food industry. Our guests are Dr. Thilo Berg and Mrs. Monika Hutzler, and they are responsible for bringing this product to market. Frau Hutzler, forgive me for breaking the ladies' first rule, but Dr. Berg, what do you think will be most likely the first areas where your clients will start applying this new biofilm sensor of yours once it is fully developed, certified, and brought to market?
Very likely systems where water is recirculating for a long time. That could be ice water systems, or in the chocolate industry, just like we heard at the EHEDG World Congress in October. In the chocolate industry, there are many jacketed tanks, and in these jacketed tanks, there is water recirculating. And to have an idea on when there is a risk with this recirculating water, that might be a huge benefit for the chocolate industry. Mm-hmm. Other applications could be air conditioning systems, where condensing water also leads to a higher humidity that always comes with biofilm development. And then another really big application could be for the food industry, producing carbonated soft drinks, also non-carbonated soft drinks, flavored water, beer, and so on. There it is always a question, how long can we actually produce?
Mrs. Hutzler, from a business development strategy perspective, what is the reason for Lörke to invest in developing this new technology?
So we as Lörke want to realize the condition-based cleaning, and to go on with it, we need to know what happens in the system. We have to know what is the need of the system when we have to clean. And so we were looking for different sensor technologies like contamination sensors, like turbidity sensors, and so on. And we think the best way to look at your system is to control your microbiological growth in your system.
Dr. Berg, these new types of sensors allow end users, food processing companies to gain a better insight in the real-time performances of their processes. That also helps them to cut down on chemical use, water use, so it improves the sustainability performance as well. Is that related to the rising energy prices? Would you agree if I say that these rising energy prices, despite the terrible reasons for them, kind of help you to bring this new product line to market?
Yes, I totally agree. I'm in that way, I'm a really big fan of these a little bit higher energy prices, because just like my colleague said, it might now actually be worth to finally get on with optimizing processes. It can be a process that takes resources, that takes time, and there has to be an invest, and yeah, now it might finally be worth it, because what you save actually brings you some dollars back to the table.
Yes, and the energy prices are high for everyone, so in that sense, it's the same conditions for everyone, so they don't have to worry for investing too much and losing the competitive advantage, right?
True, they might even gain a competitive advantage because then once it is optimized, they have an edge, so they can produce at lower costs compared to the competitors.
What would you consider to be the main differences between this new biofilm sensor and the existing contamination sensors that are already available in the marketplace?
There is a difference between the contamination sensor and the biofilm sensor. Both measures layer thickness, but the layer thickness is not proportional to the hazard potential. So you can have a very high hazard potential with a very low layer thickness if you have high shear forces in your system, because bacteria don't produce a lot of extra polymer substances, EPS, when there are a lot of shear forces. And so we decided to use this biofilm sensor to look up to the changes in the system, to look when starts bacteria to or biofilm to grow in an exponential growth phase. And then we can go in and say, okay, now we have to clean, we must clean, because the system is going to be contaminated. And this is the difference between the normal contamination sensor and our biofilm sensor, or biofilm sensors in ordinary.
Dr. Berg, you're an expert in this field, so allow me to ask you a general question about optimization of food processes. How does this optimization process relate to risk assessment and risk management?
Sometimes you find potential for optimization where you do not even take a risk. Somehow you just have to change parameters, and then thereby you can save things. That is the CIP process is, if you look at it for the first time, it's quite complex, and if you're used to it, then it's not that complex. But in some stages, for example, you have to collect your chemicals again. So your whole production cycle is filled with chemicals, and they have to get back to your chemical tank that's sitting somewhere. So you take water and you push out the chemical. It's hot. It also has temperature, so you needed resources to heat it up. Mm-hmm. And all this goes back to the staple tank, to the CIP tank. There is a sensor that measures, okay, now there is water or there is still chemicals. As long as there are still chemicals, it can all go in that tank. But it won't be a clear cut. It's not like a 0-1 switch. You start maybe at a signal of 40, and then you go down to 30, 20, 10, 8, and so on. And the question is, when does it switch? And how long does it take? So depending on how the CIP is running, this can take a very long time. And if you then say to the parameters, okay, switch in the beginning at 25, then everything from 25 to 0 gets lost.
Yes.
So there you can, without taking a big risk, save quite a lot.
To complete this interview, Mrs. Hutzler, could you please tell us in 1 or 2 sentences what you think this new development means for the future of food processing?
This is a chance for the future, that you may combine some sensor technologies like contamination or biofilm sensor or turbidity or something else to show what happens in your black box system production. And in future, you will be able to react faster to different conditions.
Monika Hutzler and Dr. Thilo Berg, thank you very much for this interview, and we wish you much success with this innovation. And dear viewer, if you are watching this and you're thinking, well, I have an interesting innovation to bring to the attention of the global food industry as well, just contact us, send us an email at editorial@ehedg.org or leave a comment down below. Thank you very much for now. See you next time.